Okay guys, in this example we'll discuss about a projectile motion within the examples of a rocket which runs out of a fuel and in the position shown and then continues in unpowered flight above the atmosphere. If its velocity in this position was 600 miles per hour, calculate the maximum additional altitude h acquired and then the corresponding time to reach it. Then the gravitational acceleration due to this phase of its flight is 30.8 feet per second square. So this example just illustrates as we can consider this one as a projectile motion because at the initials of our calculation or at this point the rocket is unpowered. That means there is no continuous supplements of fuel there, so it may have only its own initial speed and then it will project into the air. So it's a free object now, so we'll have the principles of projectile motion analysis for calculating this one. Now the first thing is just we'll take out some given parameters and then we'll list down the required parameters there. Now for the ease of illustration, let's construct the graph, which is the horizontal and the vertical position. There's x and then y here, and then we can construct the velocity at this position. So this is normally 90 minus 30 degrees. It will be 60 degrees from the horizontal axis, and then the velocity is 600 mile per hour. Normally we have to convert it into the normal standard unit as US customer unit. That means for feet per second, and then gravity is given here, which is 30.8 feet per second square. Now let's list out the required parameter. The first one is h max, is how much, and then the second one is the time required to reach at that position, so t is required here. Now how we can evaluate this equation now we have to convert the velocity, so velocity is 600 miles per hour. To convert this, first we have to eliminate mile. To eliminate mile, we'll write in the lower part, so we'll have 1 mile, and then the equivalent of 1 mile is just 5,280 feet, and then mile by mile will be cancelled out here, and the other one to cancel out this hour, we'll have 1 hour on the upper one, and then the lower part, the equivalent of 1 hour is 3,600 second. So hour will cancel this hour, so finally we'll have feet per second, and then when you calculate this, you'll get 880 feet per second. This is the velocity. Now the initial velocity in the x direction will be now v naught times cos theta. Here you are familiar with this one, so v naught is 880 times cos 60 degree. Normal cos 60 degrees 0.5, so if you multiply this one, you will get 440 feet per second. Now initial velocity in the y direction, or the y component, is v naught sine theta, which is equals to 880 times sine 60 degrees. Sine 60 is 0.886, so if you multiply that one, you'll get 762 feet per second. Now we are calculating the initial velocity component in its own direction. Okay, now let's write the acceleration in the y direction. Normally it is equals to negative g because it's opposite in the direction, so it will be negative 30.8 feet per second square in the negative direction, but it's constant because there is no any wind effect, and then also there is no power for having some unbalanced forces. So the acceleration in the way will be negative, but it's constant throughout the system in the downward direction. Now, once we have this, we can use the final velocity in the y direction is equal to initial velocity in the y direction minus gt, or simply, if you remember this one from the previous class, it was acceleration times t. In this case, the acceleration is minus g. So, and then the next equation can be written as v squared equals to v naught y squared minus 2gh, because s is now equals to h, and then to acceleration will be minus 2 gravity. So we'll have this one minus 2gh. By using these two equations, now we can solve the required parameters here. So to calculate the H max, normally the maximum height will be attained where the rocket just finishes its velocity in the upward direction and becomes 0, and then it will return to back that one. So the maximum, to calculate that one, let's apply the second equation, because it can relate the height with the velocities and the gravities. So initial velocity is 0, the final velocity is 0, so it's equals to the initial velocity in the y direction, 762 squared minus 2 times 30.8 times h max. Now here the only unknown parameter is h max, so we can rearrange this one. So if we just gather the numbers into the left direction, it will be negative 760 squared over minus times 30.8. So h max can be this one. Negative will cancel out within this negative. So h max can be this one, and then if you calculate this, you will get the value as 9,426 feet. So this is the maximum height. This is our answer, 9,426 feet. You may convert it into mile if you need, just by dividing it with 5,280. Now let's see the other calculations. Now by applying equation 1, we can also calculate the time required to just to reach over that position, or that the maximum position. So if we apply for the first equation, of the final velocity will be 0, which is equals to initial velocity 762 minus 30.8 times t. So t can be here 762 over 30.8. So finally you will get this one as 24.7 seconds. So this is the answer for the given analysis. Thank you guys for watching us. Please subscribe our channel. We'll deliver you different interesting videos.